Hi, I'm glad you came back to watch the rest of this instruction on the slope intercept formula. Very powerful formula. This guy right here, y equals mx plus b. If you can make a line equation with y by itself, you always get two free facts. The m number in the formula, m is the multiplier. Now notice it's just the m, it's not the x. The m is the slope number. So we take the -2 multiplier off the x, and that is our slope number. It's just the -2, it's not the x. M equals the -2, which is the slope. We don't have the picture, but we know that that's the slope number of this equation. So if we graph it, it'll show us the slope is -2. Now then there's the b number. The b number is the y part of the y-intercept point. So here my b number is 5, so my y-intercept points. Now points always are a pair. When mom asks you for the y-intercept point, you have to type in a pair, but the y-intercept pair is always x equals 0 and the y part of it is b. So that 5 is the b number, which translates into the y-intercept point. Now this one says plus b, this one says -4. So the b number is -4. That's my y-intercept point. Now, the slope was a decimal, but if we change 0.5 into a fraction, it's better to have slope as a fraction. That's a 1/2 slope. Here's another equation. Now this one was a little tricky, just a tiny bit, because it only had the x part. It had the mx, but it didn't have the b part. So it's y equals mx, and that's it. So the m number was the -5, we got that. But since there was no b number in this equation, in our mind we could think, oh, there's no b number. That means plus 0 is like no b. So now I know the y-intercept part. So that 0 is my y-intercept coordinate over here for the y-intercept point. Now this one was also a little bit tricky because it just had -3. It had a number only. There was no x part. So it's like we're looking at y equals, and all we're seeing is, maybe I can do it this way, y equals the b number. There's only a b number. There's no x part to it. Well, if there's no x part to it in our mind, we can say, oh, 0 times x, because there's no x's. And that means the slope is 0. Now also about this, y equals -3, we've studied that. When y equals a number, that's a horizontal line. So a horizontal line, of course, is going to have a 0 slope. Okay, now what we did here is we took from the equation, we took information out of the equation, and we can actually take this information and make a graph. I'll show you how to do that later. But now we're going to reverse that thought process. We're going to look at the graph, we're going to gather the information, and then we're going to write the equation. What is the equation of these lines? We haven't done that before. But because of the slope intercept, it's very powerful. Because we know this special formula pattern, we can look at a picture, figure out the information like the slope and the y-intercept, and then we can turn that information into its equation. For example, line A. We're going to look at the picture and find its information. Okay, so the equation needs two important facts. It needs the slope and the y-intercept point. Okay, the slope and the y-intercept point. Let's find those. Now on line A, I'm going to go for the easy thing first. I see right here is the y-intercept point. That is the point 0, 5. And we're going to do the slope. Well, if I go down from 5, 4, 3, down 2, over 2, I see the slope has a rise of -2, a run of positive 2, which equals negative 1. That's my slope. Easy to find off the picture. The picture gave us the y-intercept point really fast, gave us the slope pretty easy, and if you know the y-intercept point and the slope, then you can write the equation of that line. How do we find the equation? Well, y has a formula, mx plus b. Now, x and y are always variables. They are the xy variables that make all the points. There's infinitely many xy pairs. The m number and the b number are numbers. So x stays a variable, y stays a variable, but m is a number and b is a number, and we have the m number right here. So y stays a variable, we have the m number, x stays a variable, and we found the b number. It's the y part of the y-intercept point. It's positive right there. So y equals negative x plus 5. This is the equation that makes line A. So it's kind of working backwards. Normally we would make our points and draw the graph. Now we're reversing that. We have a graph and we're trying to find the equation that makes all of its points. Let's do that again. Line B. Okay, I have line B over here. And where does it cross the y-axis? Oh, right down there. It's the y-intercept equals the ordered pair. The x, it's on the y-axis, so there's no x. I mean, there's no forward and there's no back. So the x number is 0 and the y number is down. Okay, so my recording cut out on me right in the middle of a sentence. So that explains this little patch. But let's go back to line B. Line B is this line right here. We are looking for information. We found the y-intercept point. It's at 0, negative 1. So y part of it is negative 1. Now that means I know the b number. Okay, next I need to find the slope. Okay, well, slope, rise over run. I just need to count it. Since I have the picture already, I made 2 points here, this one and this one. I'm going to count. The run is 2. If I go left to right, the run is the 2. That's the horizontal. That's the change in x's on the bottom. The rise is up. 1, 2, 3, 4. There's my slope. And 4 over 2 equals the whole number 2. Okay, well, if we can find that information, the y-intercept point and the slope, then we can write the equation of the line. The slope intercept formula says y equals mx plus b. Now remember, x is a variable, y is a variable. They stay variables, but m is a number and b is a number, and we found the m number by looking for the slope on the picture. Y equals 2x. So the m is just the multiplier, which is also the representative of the slope steepness, 2 times x. But we also know the b number, so we could go plus negative 1. But plus negative 1 is a little awkward, so I'm just going to make it simple, 2x minus 1, and that gives me my equation for line B. All right, let's do one more of these to figure out the equation of line C. We have the picture of line C, but we don't know the equation of it. And because of this powerful slope-intercept formula, if we can find the y-intercept point and the slope, then we can write the equation. And I see the y-intercept point right there. It's down 1, 2, 3. So my y-intercept point is x is 0, y is negative 3. That's my y-intercept point. So b is free. I know the b number. Now, if I can find the slope, I can find the equation, and I can look over here on the rise and run. I have a point here and a point here. I'm going to draw the stairs and count. We go downward one step down. So my rise is -1 because I stepped down vertically. Now I move forward 1, 2, 3, 4. So my run number equals 4. Now I have a little stray mark there. I'm going to take that out. I have both the B number and the M number. Okay, well, the equation then is the M number, which is -1/4. Now it's a fraction. That's okay. Times X. There's M times X plus B. Now B is -3. So I could put plus -3, but that's weird. I'm just going to go -3. And there is my equation for line C. This is extremely powerful what we've done. And this formula can go two ways. If we have the formula, we can pull the information out and we can actually graph with that information. If we don't have the equation but we have the graphs, we can gather the information from the graph and plug that information into the equation and get the equation of the line. So we can go from the equation to the information, and we can reverse it and go the information into the equation. It's a very important skill to learn how to do the slope intercept form going both ways. All right, let's flip over to our next page here. And what we're going to study now is just kind of reinforcing these concepts. What's going on with M and B? What is the effect of M? What is the effect of B? We're going to do a little experiment. Our experiment is, okay, what if we keep B the same and change M? So we're going to do the experiment by saying, let's let 0, 3 be our y-intercept point. So B equals 3. That's not going to change. And that means the equation is y equals mx plus 3. Now, we're going to look at an experiment. What happens if we change M? What happens to the line or the lines? Now, here's a website. It's called desmos.com. I encourage you to play around with that. Desmos.com is a great website for graphing equations. And that's what I'm going to use to do some experiments to see what happens when we change M. Now, I did that a little bit in class, but we're going to do it a lot more here to see what's going on. Okay, so let's pull up the website for Desmos. All right, notice the equation over here. Y equals mx plus 3, and I have M in the equation. Sorry, yeah, I do have M in the equation, but we don't know what M is yet. And I have 3 in the equation. We do know the B number is 3, but we don't have a line because the computer doesn't know how to graph it. If there's no M, it doesn't know what it is. But we're going to allow the computer to change M and give us lots of different M's. So I'm going to create this thing called a slider. And M can be any number between 10 and -10. So M is 1, and if we look at 1, we're going to see the slope is 1. All right, so this is like saying our equation, M is 1, y equals 1 times x plus 3. And if we notice, if we take 2 points and we count over 2 up to, M is 2 over 2. It equals 1. So when we make 1 in the equation, we get 1 in the slope. Now what happens if we change the M? Okay, so I'm going to change the M and make M bigger. Let's move M up to, let's say, 4. There it is, 4. Okay, so what happened to the line? As I change the line, I'm changing the steepness. I'm changing the slope. M is changing the slope. And so if M is 4, how does that play out for us in our equation? Well, let's draw and see what happens. Okay, since I made the M number to be 4, my equation is 4x plus 3. Now, notice again, the y-intercept is still 0, 3. That hasn't moved. That hasn't moved at all. But what about the slope thing? Well, I'm going to grab 2 nice points. I'm looking for another nice point. I see one. Let's see. Not there. It's funny, the axis is counting by 2s, but that looks like a nice point. There might be a better one, but that's the first one I'm seeing as a nice point. And so I want to count the rise and the run. So the run, I'm going to go over, and the rise, I'm going to go up. And this is -2 to 0, so I'm going forward. That's a run of 2, and I went up. Now, right now, I'm in between -4 and -6, so that's -5. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. Now, we have to be careful because the axis is counting by 2s, but I'm going up 8 spaces. So m is +8 because I went up. It's forward 2, so that's a +2, and 8 over 2 is 4. The slope is 4. That matches what happened. When we plugged in 4 for m, the slope was 4. Let's do one more of these real quick. Okay, so let's make m, let's say we make it -2. There it is. So that's what the line would look like. If we took the equation and graphed it, it would look like this line. Now I want to look at the patterns of what's happening with the m. But notice again that the m changes the slope, but there's one thing that is not changing, and the y-intercept point is staying the same. That's because b is always 3. The only thing that changes is the m, and when m changes, it changes the slope of the line. So let's just confirm all of this with looking at the slope in the equation again. So I plugged in -2 into the equation where the m number goes, and that equation makes that blue line. Now let's look at that line and see what is the effect of the -2. Well, the y-intercept point, that has no effect. It's like stuck there because b is always 3, but the only effect m has was to change the slope or the steepness. And if we find a couple of nice points we can plot, here's one where we come down and then we go over and we count that. Well, we're only going forward 1 and we're going down from 3 to 2. That's 1, 2. We went down 2. So if we do rise over run, our rise is actually going down. That's negative. And our run is forward 1. That's a slope of -2. It keeps matching up. The slope of the line is matching up with the m in the formula. So the effect of the m is to make the slope change. Okay, so we had these 3 lines. I think I tried to remember y equals -1x plus 3, y equals 4x plus 3, y equals -2x plus 3, and it made these different lines. The 3 stayed the same, and notice that all 3 lines intercept at the same point. But the m is different, so they all have different slopes or different slants to them. So if we keep putting out more equations like y equals, and if we were in class, I'd ask for people to shout out numbers. Give me a number. Let's say 2.5. 2.5x plus 3. Notice it goes through the same point, but it has a different slope. Let's say y equals a fraction. We didn't use any fractions. Let's say the fraction is 2/5 times x plus 3. Everything hits the y-intercept point at the 3, but they all keep having different slopes. One more, y equals, let's say we go negative a fraction, 1 divided by 6 times x plus 3. They all keep hitting that point. Now on your notes, you have a blank screen here. You have a blank graph, and the point that I want you to capture is if the 0, 3 is our y-intercept point, b is 3, that's stuck. It doesn't change. But the m's do change. So we can make a quick graph. It doesn't have to be perfect of this where all the points are hitting 0, 3, but the lines all have different slopes. So how would that look in your notes? Just a quick set up for that. Hold on. Okay, because we're back at the notes, the y-intercept point is 3. That's stuck right here. That is our point, 0, 3. Now, if we change m, sometimes the line will go up. I'm just making random lines, and you can make random lines on your paper too. Sometimes it will slant really high. Sometimes it will slant down. Sometimes it will slant down a little bit. But when we change m, the effect of m is it turns the line so the line has a different slope on it. That's the effect of m. So we might just say here it changes the slope. M changes slope. Okay, now I'm going to do the same experiment. No, not the same experiment, a similar experiment. This time, I'm not going to change the slope. The slope is stuck at 2, so m equals 2x. But the b, I don't have a b number, and I'm going to change the b. And what is the effect if we change the b? Okay, so we're going to go back to Desmos. Look at this again, this time when b is different. All right, hang on. We'll switch over to Desmos and look at that. Okay, so you can see I put Desmos in. I put the equation 2x plus b. Since I don't have a b number yet, the computer hasn't graphed anything. And I'm not going to do the slider thing. I mean, I could. And we see that the graph is moving. But what's not changing? They have the same slope, all of these lines. But I think here I'll just put down several lines as examples. So let's make b equal to 1. We get a line. Let's try another one. Y equals 2x minus 3. Got another one. Y equals 2x minus 5. Got another one. Y equals 2x plus 4. Got another one. Y equals 2x plus 0. Now we don't have to type 0, but notice that one hit right at the origin 0, 0. And so what's happening? Well, what do we notice about the lines? They're parallel. They have the same slope. Every one of these has a slope of 2. That's not changed. The only thing that is changing is here's the y-intercept point at -5. Here's the y-intercept point at -3. The y-intercept point at 0. The y-intercept point at 0, 1, and the y-intercept point at 4. So when we change b, the effect of b is to change the y-intercept location. So in effect, these lines are just moving up and down. The slope stays the same, but the y-intercept is sliding. If I change b from -5 to -3, imagine the whole line sliding up to be the purple line. If I change b from -3 to 0, imagine the purple line sliding up to be that blue line. And if I change b to be 4, imagine the blue line sliding all the way up to be the red line. It's exactly what's happening here. So let's get that captured in our notes. Now we can't be so random on this one because we have the slope. That's a little bit more complex. We have to get the right slope. And so if I change b to be like the number 4, how would I draw that? Y equals 2x plus 4. Well, 0, 4 is the y-intercept. Got that. The slope is 2. M is 2 over 1. That means the next point is going to have a run of 2. It's going to go over 1 and a rise of 2 up 2. I can use the slope to count over 1 and 2 to take me to the next point. And that would be my 2 points that I need for this graph. And I got a line. Okay, now, if I change the b to be, let's say, 1, b is 1, oh, that would be a 1 here. That would be a y-intercept of 1 down here. Now, the slope is still 2, it has to go over 1, up 2, and it's going to have the same slope, but it hits a different y-intercept. And if I go down to -1, I'd be down here on my y-intercept. It's going to have the same slope. It's just going to hit the y-intercept at a different number. If we did 7, if b was 7, I'd be hitting here, and it's just going to have the same slope. So the effect of b is that it changes the y-intercept point. It slides it up or down depending on the b number. Okay, we are almost done with this lesson. Hang in there a little bit more. One important observation. If you look at this particularly, these lines are what we call parallel. They go straight forever and they never cross each other. Any line that goes straight forever and never touches another line, we call those parallel lines. Now, when you have parallel lines, it means parallel lines are always going to have the same slope. All of these lines, the slope equals 2. Every line that's parallel. Now, the slope might be different. It might be -1/4. Go down 1/4. And another parallel line to it would also go down 1/4. And they're going to be parallel if they have the same slope. And they won't ever touch. Now that's an important fact to remember. And we're going to use that fact to do something that takes a little thought. But this is a skill we want to build. We want to write the equation of a line that passes through a point 3, 6 and is parallel to this line, y equals 1/3 x minus 2. Okay, write the equation of a line. All right, so we need a new line. A new line equation. Okay, now what do we have to work with? We have the old line. The old line equation, y equals 1/3 x minus 2. Okay, now we're looking for a new line. Now the new line equation will follow y equals mx plus b. I can make the new line equation if I can find the m number and the b number. So we've got a job to do. We're going to have to find m for the new line. And we have to find b for the new equation. Okay, now what clues do we have? Well, the new line is supposed to be parallel. The new line is parallel to the old line. Well, wait a minute. What is the equation of the old line? I'm sorry, I said that wrong. If they're parallel, their slopes are the same. Wait a minute. We know the slope of the old line. M is 1/3. So if the old line is 1/3, that's the slope of the old line, and the new line is parallel, then the slope of the new line has to be the same. Okay, so we just figured out the slope of the new line. Now we haven't figured out the b number yet, but we've got a big step forward. Y equals 1/3 x plus b. Now, we do not have the b number yet. Now we need to figure out the b number. Okay, now x is a variable, y is a variable, and x and y are the variables for all the points on this green line. Now we've used up the parallel fact, but we haven't used this fact yet. We've got another fact. The point 3, 6 is on the new line. So this 3, 6 is a point that's supposed to work in my new line equation. So wait, that gives me an x number of 3 and a y number of 6. And I have an unknown number of b. Now if I stop here, I have b, I don't know, I have x as a variable, y as a variable. I can't go too far. But because I have this one example, I have an x number and a y number to plug in. If I take this x number, y number, and plug it in, then I know an x number, an m number, a y number, and the only thing I don't know is the b. I can figure this out with algebra. So I'm going to plug in this y number for 6. I'm going to plug in this x number with 3. And after plugging it in, the only thing left is an unknown b number. So by plugging in this point for the x's and y's, I made an equation with only b unknown, and I can do a little bit of algebra and figure out the b. So I'm going to simplify. 1/3 times 3 is 1 plus b. Easy algebra. I can figure out b minus 1 on both sides. 5 equals b. So I know the m number for the new line, and by plugging in a point on the new line, I've solved for the b number on the line. So now I know y equals 1/3 x plus 5. Now how could we check this? If you wanted, you could type that into Desmos. And type this one into Desmos. Type in the old line into Desmos. Type in the new line into Desmos. And we should see a picture of two lines that don't touch. They should be parallel, and they intercept at different points. I'm not going to do that for the sake of time. We've already gone a long time on this. I'm going to quit here. So hopefully that helps you. I want you to really study hard now on 3-4, 3-5, and I'll see you in class on Monday. Bye-bye, everybody.